Hey everybody, this video is for the 2.4 homework on acceleration. I got some awesome feedback from you guys that we were needing more guided practice with problem solving. So I'm planning on making instructional videos for all of the homework assignments. The trade-off is that we are going to have a weekly quiz on Fridays. Okay, so that's when you guys will show me your understanding. But for the homework, I really want it to be guided. I don't want you guys to be struggling on your own. I want you to make sure you have resources you need. So I will be uploading these frequently. Okay, so this worksheet is on acceleration. We covered acceleration with the POGIL, and we also went over some PowerPoint notes. So in question 16, we have 4 motion diagrams, A, B, C, and D. And then we are supposed to fill out this table with the sign of the position, velocity, and acceleration. So remember that position is x, velocity is v, and acceleration is a. And then the subscripts in our table are the times. So this would be x0, so the initial position at time equals 0. This is y0, the initial position along the y-axis as at time equals 0. This is our x position, y position at time equals 1. And then when you see ones with subscripts that say 0x or 0y, that would be the x velocity and the y velocity. Okay, and that would depend on if we have horizontal or vertical motion. Okay, so let's take a look at this first motion diagram. In A, we see that our object is starting at 0, and its position it's going to the right. So that means that we have a positive velocity. Okay, so our initial position is 0, so we're going to put a 0 in the box. We know that because we see that the first particle on our diagram is labeled 0 at x equals 0. Okay, at the point labeled 1, we see that our object is at a positive position. It's moved to the right, so along a number line, numbers to the right of 0 are positive. Okay, and then its velocity at time equals 0 is going to be positive. And then its velocity at time equals 1, it says that it stops. So that means that it has 0 velocity at the end of its motion. Okay, and lastly, the acceleration, if it's going from having a positive velocity to a 0 velocity, that means that its acceleration is negative. The object is slowing down. I also wanted to clarify why the velocity was 0 at the beginning, positive. If it doesn't say that it has an initial velocity, we'll see later in D that it does, you're going to assume that the initial velocity is positive, okay, if it's moving in the right direction. Okay, but if it's starting from a stop, then the initial velocity would be 0. Okay, so that's motion diagram A. Motion diagram B, we are starting at 0, okay, and then we are moving to the left. So we see that our object ends up at time 1 at a negative position. So x1 is going to be negative. And then the velocity at the beginning is going to be 0. And the way we can tell that is it says it starts here. We see that the dots start out really close together, and so that gives us a good idea that it's starting from a stop, starting from an initial velocity of 0. Okay, and then the velocity at the end of its motion is going to be negative. And the reason it's going to be negative is because we see that our object is moving to the left. If it's going from a 0 velocity to a negative velocity, the sign of our acceleration is going to be negative, right? Our object is, its velocity, even though it's going to be a bigger number, it might be like -5 here and then 1 over here, it's going to be negative because our object's moving to the left. Okay, now let's look at C and D where we have vertical motion. In object C, we have an object starting from a position of y at 0, and then it's accelerating in the upward direction. Okay, so maybe it's a rocket taking off. So our initial y position would be 0. Okay, we see that our first coordinate here along y is 0 at time equals 0. And then at the end of its motion, at the point labeled 1, we see that y is going to be positive. We know along y-axis, the positions above 0 are going to be positive, just like on your coordinate plane. Okay, and then the initial y velocity, which is what v0y means, is going to be 0. Okay, we see that our dots start off really close together. The object maybe is a rocket. It's not moving at the beginning, and then it's going to take off and accelerate in the upwards direction. Okay, and then the velocity at the end of its motion is going to be positive. We see that our object is speeding up. So it's going to have a positive velocity when we take that t=1 snapshot. Okay, lastly, its acceleration. We see that our velocity is going from 0 to positive. So the sign of our acceleration is going to be positive. Okay, you always have to remember that both velocity and acceleration are vectors. So it's important to know if it's going to be positive or negative. It tells you that direction that's associated with those quantities. Okay, and then D. We've got an object starting up here. We know it starts up here because this is labeled t=0. And then it's falling. We see that the dots are getting farther apart, the object's speeding up. So this would maybe represent a falling object. Okay, so our initial y position is going to be positive. It's above 0. Okay, so it's starting at some y position up here and then getting dropped. So its position at t=1 is going to be 0. Okay, we see that marked here. As far as its velocity in the y direction, it's speeding up in the y direction, but it's going down. So our initial y velocity is going to be negative. Okay, it says it has an initial velocity. And then our velocity at the end of the motion is going to be negative, but it's going to be a bigger negative number than its initial velocity because we know the object is speeding up. So if the velocity here, I'm just making up numbers, let's say it was -1 meters per second, and at the end of its motion, v1y, it is -2 meters per second. The change in velocity would be a negative change because -2 is less than -1. So its acceleration is negative. It's speeding up in the negative direction. Okay, let's move on to question 17. I'm going to zoom in a bit here. So we looked at different combinations of symbols for position, velocity, and acceleration. There's actually 8 possible combinations of signs that would make sense. Okay, and we know that there's 8. Because we have 2 different signs and then 3 quantities. 2 to the 3rd power is 8. So you could figure that out if you've taken any sort of probability or statistics classes before. So every possible combination of these signs we could draw a motion diagram for, which is what we're actually going to do on the back side. So to list them, you're just going to think about all the different ways we could put together negative, positive for x, v, and a. So if we were going to list them out, x, v, and a, we could say maybe x is positive, v is positive, a is positive. Or maybe the position and the velocity are positive, but acceleration is negative. And then we'll fill in the rest of these. I'll leave the rest for you to do. Okay, so just think about all the different ways we could combine those. Okay, feel free to pause the video if you need some time to think about these. But I'm going to turn the page. So for each of our 8 combinations of signs for velocity, position, and acceleration, we want to draw a motion diagram. Okay, and it says to use black and red for your velocity and acceleration vectors. Okay, so hopefully if you have a red pen. If you don't, maybe draw dashed lines for your vectors for the red, whatever works for you, that you just need to be able to differentiate them. So we will start with if velocity, position, and acceleration are all positive. So I'm just going to list the signs over here to the right to organize our work. So we've got x, v of x, and a x. So this is the velocity and acceleration in the x direction. And our first combination, let's do when they're all positive. So we want to draw a 4-dot motion diagram, okay, and then label our vectors. So if we are starting out at a positive position, our first dot is going to be, and you can do it above the line, I think that's the best way to do it. Our first dot, time equals 0, is going to be to the right of our 0 on our x-axis. So here's 0. And then its velocity is positive, so we know our object is traveling to the right. If it was traveling to the left, it would be negative. And then our acceleration is positive. It is speeding up in the positive direction. So our next 3 dots, you just want to draw them getting farther apart because our object is speeding up. So maybe the next one is here. Next one's a little farther away. And then we could put our last dot here. Okay, I don't care if you label all these dots, 1, 2, 3, 4. What's important is that you're marking where 0 is. Okay, I know our diagram's gonna get a little crowded. Okay, so next let's draw our velocity vectors. It says to do these in black. So remember, velocity vectors just connect the points. So this would be v1, v2, okay, v3. Okay, and it's important that these completely connect the points because the length of the vectors are magnitude of the velocity. It's our speed. Okay, so acceleration. We know that our acceleration is positive. Our acceleration isn't going to be changing. If it was, it would be called jerk. If you want to offend somebody in physics, you could say that you're the rate of change of acceleration, like you're a jerk. So our velocity is not changing. The length of our velocity vectors is going to be the same for the 3 ones we're going to draw, but the direction is important. We know that they should point to the right because our object is speeding up in the positive direction. So let's do the first one here. Okay, you can just label it A1, and then the next one, wherever you can fit it, A2, and then A3. Okay, these should all be the same length as each other, but shorter than the velocity vectors. We would need more information to determine their actual length. So it's important that you show them pointing in the right direction and that they're all the same length, the same magnitude as each other. Okay, we're gonna do a couple more. Let's do it when position and velocity are both positive, but acceleration is negative. So if position is positive, just like last time, we are going to start off to the right of 0. Okay, anywhere you can fit it. That's where we'll mark time equals 0. And then velocity is positive, our object is moving to the right. And then acceleration is negative, so that means that it's slowing down. So we'll start off with some initial velocity to draw our 4 points, but then we see these dots get closer together as time goes on, okay? Our object's slowing down, but it has a positive velocity because it's moving to the right. Okay, now let's draw our velocity vectors. So we're just gonna draw arrows connecting our points. Okay, we'll label them V1, V2, and V3. acceleration vectors, we know the acceleration is negative, so they're going to point to the left. Okay, acceleration vectors point to the left if your object is slowing down along the x-axis. So they're going to be the same magnitude as each other, right? Because we don't have any jerks in here. And just do your best to draw them near each of the segments. So here is A1, A2, and A3. Okay, oops, I forgot my arrows over the vectors in example 1. We definitely need to do those. And we see that our vectors point to the left. Okay, our object is slowing down and has a negative acceleration. Okay, let's move on to number 3. I think I'll do one more with you guys and then leave you to try the rest. Okay, so the next one I had on my list was positive initial position, positive, or excuse me, the next one I have is negative velocity and positive acceleration. So let's think about what it would look like if its initial position and acceleration are both positive, but its velocity is negative. So our initial position is positive. So just like last time, the other two examples, you can draw your t equals 0 dot there. And then its velocity is negative, so it's moving in the, oh, I didn't leave enough room here. Draw your 0 over here, and I'll show you why we need to do that in a second. It's moving to the left, okay? So it's moving to the left because it has a negative velocity, but is it going to be speeding up or slowing down? It's going to be slowing down, and the reason that is because it's traveling to the left, okay? So I'm going to draw the particles for you, and then we'll talk more about how we know that it's going to be slowing down. Okay, so it's got some initial velocity, and then it's going to be getting closer together. Okay, so let's draw our velocity vectors. We know that they point to the left because our object is going to the left. Okay, V1, V2, V3. Okay, so let me zoom in here. So our velocity vectors point left because our object is slowing down. Or excuse me, because it's moving to the left. Our acceleration vectors are going to point to the right. So we can label those A1, A2, and A3. And that's because our object is slowing down, but if it's moving to the left, that means that if it's slowing down in the negative direction, it would be speeding up in the positive direction. That's kind of weird. So a trick to tell you the sign of the acceleration vector, what way it points, is it's going to point opposite of the motion if your object is slowing down, and with the motion if it's speeding up. I think I actually will do one more example with you guys where acceleration and velocity point in opposite directions, just so we get the hang of this. So let's try drawing a motion diagram when, which one should we do? Let's do when position is negative, velocity is positive, and acceleration is negative. Okay, so if position is negative, our object is going to be starting to the left of 0. Okay, I'm going to zoom out a little bit. So we'll put it here, maybe. Its velocity is positive, so it's going to be traveling to the right. But it's going to be slowing down, okay? Our acceleration is negative, so it's going to be slowing down to the right. Okay, we'll draw our velocity vectors connecting these 4 points. And then our acceleration vectors, since it's slowing down, they're going to point in the direction opposite of the object's motion. Okay, that's the trick I told you before. So they are pointing to the left. They're all the same length as each other. The object is accelerating at the same rate. So here's A1, A2, A3. Okay, so summary. When objects have opposite signs of their velocity and acceleration, the vectors are going to point different ways. Okay, you need to think about if it's speeding up or slowing down in the positive or negative direction. If it's slowing down, acceleration vectors are going to point in the opposite direction of the motion. Let's write that down somewhere actually. So wherever you can fit it on your paper, I'm going to grab a sticky note. So acceleration vectors point in the opposite direction of the motion if the object is slowing down. Okay, so I'm going to leave the rest of these for you guys to try. Again, we're doing all 8 combinations that we saw on the last page. Please try to color code it. I don't care if you use red and black. Just use 2 different colors for your velocity and acceleration vectors. Make sure that you're labeling your vectors properly. They should have a little arrow above them showing that they're vectors, and then also the subscript. Again, I don't care if you label all the time points, just mark where 0 is. Yeah, I hope this video was helpful to you. And again, we will have those weekly quizzes on Friday because I'm helping you guys more with your homework. Okay, see you in class.